Hello, my name is Kelsey Limbaugh. I'm a rising junior from Easley, South Carolina. My major is Material Science and Engineering with the Polymerate Materials concentration. My interest in chemistry, math, and physics led me to choose this field. When I graduate from Clemson, I would love to research and develop new and improved materials. Ideally, I would want to work for Boeing to help engineer and test polymeric materials to be used in aircraft and spacecraft. These materials must be able to withstand enormous stresses and harsh conditions. Boeing is one of the largest producers of aircraft, rockets, and satellites. Polymers are long chain-like molecules made up of numerous repeating units called monomers. In order to calculate the molecular weight of a polymer, two methods can be used: the number average molecular weight and the weight average molecular weight. I will show you how to calculate the number average molecular weight. This is calculated by summing up the product of a certain fraction of molecules and the molecular weight of the molecules in that particular fraction. In the data shown, the first column represents the molecular weight of a certain fraction of molecules, and the second column represents the fraction of molecules with that molecular weight. Given this data, the number average molecular weight would be calculated by multiplying the first column by the second, then taking the sum of these results. In this example, the resultant molecular weight is 29.28 grams per mole. The degree of polymerization determines the extent to which a molecule is polymerized by relaying the number of repeat units of the material. One interesting thing about polymers is that they can have the same chemical makeup but different properties depending on the length of the chain of molecules. Two samples could have the same composition, but if one has a higher degree of polymerization than the other, it will have increased strength and a higher boiling point. Engineers and scientists can use the degree of polymerization to predict the strength and resilience of a material. It is calculated by dividing the number average molecular weight of the polymer chain by the molecular weight of a single monomer. One polymer being used in aircraft applications is polyvinyl diene fluoride. It is mainly used in aircraft insulation. In order to calculate the strength of one molecular chain of PVDF, an engineer may need to calculate its degree of polymerization. For example, if the number average molecular weight of a PVDF molecule is given to be 96,000 grams per mole, the degree of polymerization can be calculated in the following way. The formula for PVDF is C2H2F2N, which means the weight of one monomer is equal to the weight of 2 carbon atoms, 2 hydrogen atoms, and 2 fluoride atoms. When the number average molecular weight of the molecule is divided by the molecular weight of a single monomer unit, the degree of polymerization is calculated to be 1500. Scientists can use this information to determine how successful they were in making a long chain of polymers and thus a stronger material. I hope this video has been helpful to anyone interested in majoring in material science and engineering and has given you some insight into this wonderful field. Thank you for watching.